So with that brief introduction, let's learn how to use Git. And in order to do so, I need to qualify this and say that we have to learn a lot of vocabulary and some core concepts before we can actually dive into using commands. So I really like this quotation from Sharon Cikeli. She says, Git frustrates me because while it is an excellent productivity tool that lets scores of developers collaborate on a single code base without clobbering each other, it asks its users to understand how it works at its deepest levels. It's like if you were going to write a letter and first had to read a treatise on UTF-8 encoding. And this resonated with me because I tried to learn Git a few times over the years and got frustrated when there was a conflict, which we'll cover later, and it just sort of started from scratch instead of figuring out how to fix the conflict. So you do really need to have some background information before Git can be useful, and we'll cover that in this presentation. So in order to do so, I have this sort of glossary of material where I stylize my slides as the pages of a book. And when it looks like a book, that means that we're covering some vocabulary and we're not actually looking at commands or things that you do from the command line to actually use Git. But by taking a step back to see the big picture, I think this will really help when we do start looking at actual commands. So the first important concept to be aware of is the concept of the repository, which is where the revision history of a project is stored. It's a hidden directory named .git within the directory your project resides in. Now this directory's name starts with a period, which means it's hidden, and depending on the settings of your file browser, you might not actually be able to see it, but you probably won't need to because we'll use commands to interact with this repository. So when I first started using Git, I would run things like git init, which we'll see later is how you initialize a new Git repository. And it would say, all right, I've initialized a new Git repository. And then I'd look at my directory and I wouldn't see anything and I'd have no clue how Git was actually working. So just know that your project history is just a collection of files in the same directory as your project. Now there are a few important things to note about repositories. First of all, if you delete that .git directory, you lose all of the information that Git has, which is your project history, and you're stuck with the current state of your files, so don't do that. If you make a backup copy of your project directory, which contains .git, you also make a backup copy of your Git repository. So we always recommend backing up your important files. If you send your project directory, which includes .git, to another person, that person can see your project history. And finally, you should avoid storing sensitive information or passwords in a Git repository, especially if there's a possibility that you might share your work with others, such as on a host like GitHub. Now, Git doesn't actually keep track of every single change you make. It's not the same thing as having an undo button like you might see in some other collaborative software like Google Docs, right? It's not the same thing as having a file history. So you make discrete commits with Git whenever you see fit. So there's this quotation from the book Pro-Git, which is actually available for free online on the Git website, where it says, with Git, every time you make a commit or save the state of your project, Git basically takes a picture of what all the files look like at that moment and stores a reference to that snapshot. So you're choosing to take a picture of your files. It's not constantly recording them. Now, commits have metadata. This includes the committer and the author, which is often the same as the committer, but not always, the time at which the commit was made, and a message describing the changes. Every commit also has an associated hash, which in this diagram at the bottom here is this unique ID. It's just a string of characters. And this is the name of the commit according to Git, and it's how you'll reference it in commands. But of course, this is a super long string of random characters. So in order to actually use this in practice, you can truncate it or shorten it and use just the first few characters. And as long as that's unique, it's a-okay. Now Git stores the files that you have in your project directory every time you make a change to them. And if an identical file already exists, Git will just refer back to that for the sake of limiting the storage usage of your Git repository. Now before you can make a commit, you have to tell Git which changes you want it to keep track of. So you'll first work on your files in what's called the working tree. This is just your files as you see them, like in your file browser or in a text editor, or really in any software. And then you move files with changes that you want to commit to the staging area or the index. And only the changes with files in the staging area are included in commits. So you can make changes to files and not add them to the staging area, and they won't be a part of your commits. That's a very important concept to keep in mind as we move forward. All of your commits together form what's called a directed acyclic graph. So the graph means that you have these commits, which are the vertices, and these are related to each other. They're connected by edges. The directed part of this means that commits refer back to other commits or earlier versions. These are often called parent commits, and there's a direction inherent to relationships between commits. And the acyclic part means that if you follow the graph from a commit, it won't appear again. It cannot be its own parent, no matter how many generations removed. So a version of your project cannot be based on itself, it can only be based on previous versions. And therefore there are no loops in the graph.